Good afternoon. This is my CSC480 Artificial Intelligence presentation. I'm going to briefly discuss multi-agent systems and some related topics. So, distributed artificial intelligence is a subfield of artificial intelligence that came out in 1970 and was focused on the interactions of intelligent agents. Its goal was to solve the typical problems in artificial intelligence, such as reasoning, learning, planning, and decision-making, by distributing the problem to autonomous nodes, also known as intelligent agents. These distributed agents, they performed independent processing, and they were able to interact and communicate with other agents, improving the problem-solving capabilities of earlier non-distributed systems. There are two main types of distributed artificial intelligence: distributed problem solving and multi-agent systems. Distributed problem solving is concerned with the decomposition of a problem into parts that can be processed in parallel by distributed agents, and with the integration of these results. Multi-agent systems, the primary focus is the coordination of the agents, their ability to communicate and share their knowledge and actions. Some properties of multi-agent systems are that the agents are autonomous or semi-autonomous, that each agent only has a partial knowledge of the environment, and that there are no centralized or controlling agents governing the behavior of other agents. There's a lot of active research in the area of multi-agent cooperation and coordination, and two examples are multi-agent planning and organizational structure. In multi-agent planning, the agents formulate the plan specifying their necessary actions to obtain a certain goal, and then each agent carries out its designated part of the plan. There's not really any deviation from the plan, and each agent is potentially aware of what the other agent's actions should be. Alternatively, there is an organizational structure where the social interactions of the agents are determined by the control relationships defined within that community. Some of these organizational structures can be functional, where the agents are separated by function, and some are spatial, where they can be separated out by location. Emergent behavior is something that you'll see exhibited when agents are governed by a simple set of rules, and complex higher-level patterns of behavior come out of this. Often an unpredictable side effect of a system rather than planned into a design. One example of emergent behavior is the program Boids by Craig Reynolds. I'll show an example of this at the end, but this program is governed by three simple rules: to maintain a certain minimum distance between nearby animals, to steer toward approximate direction toward which the rest of the animals are headed, and to move toward the average position of all nearby animals. These simple rules illustrate a pattern of emergent behavior that arises. Another example of emergent behavior is swarm intelligence. Simple agents interacting with each other and their environment are referred to as a swarm. And seemingly intelligent global behavior can emerge from the local interactions between the individual agents, and the agents have no knowledge of the global patterns. In contrast to swarm robotics, swarm intelligence typically refers to a set of algorithms. And many of these swarm intelligence-based algorithms replicate systems found in nature. Some examples would be algorithms based on ant colonies, the foraging behavior of bees, gravitational attraction of mass, the immune system, or water erosion. Some of the more mature applications of swarm intelligence that we see today often include optimization or search issues, airline assignment to airport gates. You see swarm intelligence used in art and animation, as well as data mining. And some future applications of swarm intelligence would be planetary mapping. That's something that NASA is doing research into now. And also nanobot control. For example, controlling nanobots inside the body tasked with seeking out and destroying cancer. So I'll show you an example of emergent behavior here. This is the Boyd's program running through processing. If you've never used processing, I find it quite interesting. But you will be able to see patterns emerging through the 3 simple rules that each of these agents are controlled by. So this is JBCourson. I appreciate your time.